Our next speaker is Mr. Peter Weismantle, Director of Supertall Building Technology at Adrian Wilson and Gordon Gill. Peter has been involved, of course, on Burj Dubai, and also he is also involved on probably the next tallest building that's going to happen is the Kingdom Tower. Peter oversees the development of the firm on all the tall buildings. He's going to talk to us about the fire and life safety for the new generation of super tall buildings. Please.
Thank you very much. There's a correction. This is actually a joint presentation, and James Antel, the Executive Vice President International of Ralph Jensen and Associates, is my joint presenter. As a matter of fact, he put most of this together. I can't take all the credit for it.
Didn't,
yeah, the book is wrong. Yeah, the book is wrong. So let me just, okay. Jim, well, I'll start off. I'm kind of the setup man, and then I'll let Jim carry on. But we are going to talk not so much about just Burj Khalifa. We want to talk a little more in a little more general way. You know, why do we build tall? And if we are building tall, we know we have to build tall safely. We'll talk a little bit about trends in super tall building design and construction. We'll talk about the operation and maintenance issues, and then kind of wrap it up. But starting with why do we build tall, and it really goes back to global urbanization. And I think this is one of the key subjects of the council itself, Council on Tall Buildings and Urban Habitat, is that as we urbanize, we are going vertically. And I think most people in this room probably know, about 2 years ago, we reached a historic point in the history of mankind, if you will, in that more than 50% of the world's population was urbanized. That's the first time that ever happened. Why else do we build tall? While talking about urbanization, this is one of those famous shots of, I don't know if you can see it in the back there, but this is Dubai in 1973, and then this is Dubai in 1990, and this is Dubai in 2006. And you can see the massive urbanization, and of course, the Burj Dubai, the Burj Khalifa, is kind of that exclamation point, if you will, of this multi-decade process. Photograph. If you remember the first photograph, if you look at these buildings, that's what it was, and this was actually about 2006 or 2007 when this photo was taken. So we are in historic times. Why also do you build tall? You build tall for economic efficiency and to maximize land value. Everybody knows the example of New York, and it seems like the rest of the world. Well, New York was this part of New York was really developed starting around the turn of the 20th century, and up until the late 20s when the economic crash happened. But it's an example that has been followed in many places around the world. There's also the potential for sustainability, and again, the council talks about that. There will be other presentations that will talk about sustainability. But if you compare the footprint of Burj Khalifa, which is on about 25,000 square meters, with a floor FAR of 12, with overall loss of, if you will, productive land of 2.5 acres. If you went to suburban Chicago, where it's actually, this isn't even suburban, this is actually in the city of Chicago itself, that footprint to house the same number of people would be 3.3 million square meters. It's a rate of development that, if you extrapolate it across the face of the earth, is just unsustainable. So that's kind of the big picture. A little bit of the little picture is the differences between an urban tall building and a suburban single-family house, if you will. There's a great deal of efficiency. Tall buildings themselves, maybe not on a square foot basis, be wonderfully efficient, but if you look at it in the bigger picture, the picture of urbanization, they are very sustainable and very efficient. Why do you build tall? Also, you want to maximize your purchaser's value, and this gets into the economics, and we can't forget the economics. And that People will pay for superior views. They'll pay for proximity to the excitement and to other people. People will pay to be near other people. And when you're building tall, why do you build a super tall? And this gets into the area of creating a landmark. And there are many examples: Burj Khalifa, the John Hancock in Chicago. They also tend to be catalysts for economic development. These are like exclamation points around which a city can be built. So the first picture was Pudong in probably the 30s, and then this photograph is what it is today, and it will be getting even more dense as Shanghai Tower gets built, etc. It's also a symbol of prestige. There's a phenomenon now of the last 10 or 20 years with building buildings that kind of are your entry into the world, and a building like the Petronas Tower is really an example of a continuation of the example of the Empire State Building in New York. In the case of the Empire State Building, it is actually funded by General Motors. In the case of Petronas Towers, this is funded more or less by the government, putting Kuala Lumpur onto the map, if you will. And then, of course, there's the creation of icons. And icons are something that every city wants. They want to be known for something. And these are you can show this to a school child anywhere around the world, and they'll say, that's Big Ben, that's London, and that's the Eiffel Tower, and that's Paris. And they know it. It's a symbol of the world. But also, beside being iconic, they tend to be egocentric. And this is my favorite slide, the Donald. And this is the building. This is Trump Tower in Chicago. It only takes two things to build the world's tallest building. It takes money, a lot of it, and it takes ego, a lot of it. And I think all the buildings, all these Supertalls that we're talking about, there's enough of both of those to go around. I think everybody knows the story that Trump originally came to Chicago, or not him himself, but his guys came to Chicago on 9/11 with the intent of building the world's tallest building. They left Chicago later that day by car with the intent of building the second tallest building in Chicago, which is still a successful building. Anyway, recent planning and architectural trends go again back to urbanization, the densification of urban development, placemaking, and value creation. And all three of those are exhibited in the Burj Khalifa, the development around the Burj Khalifa. And you've seen this before. Ahmed, we both have the same source of slides. But the fact is that Burj Khalifa is really the center point of land that had really no value until it was there. And so it created a massive amount of value. We all know that now we know Dubai has had its trouble, but the fact is that the area around Burj Khalifa has been kind of a success story. And we know that the projects that are closer to Burj Khalifa and have a view of Burj Khalifa have a much higher value than the projects that are further away and then don't have a view. And there it is today. I'm going to turn it over to Jim now, who will do the heavy lifting and talk a little bit about some of the challenges that we faced in designing Burj and working with the local authorities, and kind of the breaking new ground in general.
Great. Thank you, Peter. Good afternoon. Talk a little bit about some of the trends and factors that we've seen both in Burj Khalifa and more recently with respect to the fire and life safety aspects of super tall buildings. And one of those is that these are world-class structures. No matter where we build these facilities, they're not only competing in a local marketplace, but they're also competing globally. They're competing with buildings all over the world for tenants. They're competing for investors. And there's an expectation that these buildings have a level of safety that's consistent with world-class buildings throughout the world. The second factor is what I call traditional approaches for non-traditional structures. We've heard a lot about new technologies. I think the structural engineers really push the envelope on new technologies. Vertical transportation is always looking for new technologies for taller and taller buildings. Fire engineers have a little bit of a different bias. We tend to look at tried and true systems that have been around, traditional systems and approaches. But what we look at in super tall buildings is how do we make them more reliable, how do we make them more redundant, more robust, those types of things. And those are more of what we're looking at in super tall building design. One of the other factors that we've seen certainly since 9/11 is much more of an emphasis and much more thought about not only fire events but non-fire events and working more closely on different scenarios and different events that can affect a building. And finally, we've also sort of traditionally seen design the building, build the building, turn it over to the owner and let them operate it. And there really needs to be much more integration. This is a trend that we've seen certainly on Burj Khalifa. We got involved early in the design of the project. We worked with the municipality and the fire service very early on. And throughout the process, as the building began to turn over for occupancy, we worked with the management company and developed emergency response planning and training and all of those sorts of things. So kind of taking the whole process from the beginning through occupancy and so a little bit of framework, and this is the kind of the approach that we've taken on a lot of our projects, certainly Burj Khalifa, but others as well. In terms of the regulatory framework, you're always dealing with local building codes and local building standards. Virtually everywhere that we've worked, there aren't any local building codes that really address an 800-meter building or a 1,000-meter building. And so these are always very unique structures. But the starting point is always what do the local codes require and how do we deal with the requirements there. And then the sort of second thing is we want to build a world-class building, as we discussed earlier. So we look at international standards and international practices, what was done on the previous world's tallest building, and how do we apply those lessons to this facility. And then finally, again, building codes, even international building codes, don't really address super tall buildings. So we are always looking at enhancements, fire and life safety enhancements to the building design to address the unique issues for super tall buildings. Just a word about the approval process, because it was very important on Burj Khalifa. We got involved very early with the Civil Defense Authority, and we worked with them throughout the design process and even into construction and occupancy. One of the issues is always with this type of a project, it goes on for 5 or 6 years, and so maintaining continuity on all sides of the project team becomes very, very difficult. And so the more formalized and more regular the process is, the more that helps when there are changes to the project team. As I mentioned, we worked with the fire officials early and often, and we established kind of a working group where there people would come and go from the group, but there was at least continuity in terms of what had been done before, and there was sort of a project history of so. Trends for the new generation, and talk a little bit about some of the technical aspects of this, and both with Burj Khalifa and beyond. So, we're now designing for non-fire related events. We're working with our security consultants, working with the architects, structural engineers, working with the whole team to look at different scenarios and how that might affect the building, how we need to be able to respond to that various emergency situations. So those can be anything from a building fire, a terrorism event, extreme event like that, or even weather-related issues. Some of the design features and some of the things that we've seen as kind of an outcome of this. IBC now has specific requirements. These are a result of the NIST report on the 9/11 events. And there are specific requirements now related to structural, related both to the structural integrity of the exit enclosures and elevator hoistways, also related to spray fireproofing, and increase in fire resistance for super tall structures. One of the things that we've seen commonly, and this was incorporated on Burj Khalifa, where we've incorporated the stairs, the emergency elevators, all of the elements and life safety system risers, all within the concrete structure. So it's protected, it's embedded within that hardened structural area. The other thing that we've seen as kind of a result of 9/11 is designing for partial building system failures. And so this is where we get into more redundancy of systems, robustness of systems. I'll show you a couple of examples of this. So for example, emergency power systems where we have redundant generators, we have redundant risers within the system. And then the system can operate, if there's a partial failure or a single failure of the system, it doesn't affect the overall impact. Similarly, water supply, so fire protection water supply. This is a Burj Khalifa example where we have a series of tanks at various levels. We're able to both pump water up, and then water is supplied by gravity into the sprinkler and fire alarm systems. So there's a redundancy. If we had a fire up in here, we can pump water up to replenish the tank. If there's something in this zone, we have water above. So there's a redundancy in the system, both upward and downward. One of the key things from Burj Khalifa and most of our projects now is designing for full building evacuation. And it's not only the terrorist event, it's something as simple as losing power, losing air conditioning in Dubai in the middle of the summertime. If you have an extended loss of air conditioning systems, you're going to need to evacuate the entire building. And so there's the elements there that we have incorporated, areas of refuge. This has become kind of a de facto standard on most of the projects that we've been involved in. Areas of refuge are generally every 20 to 30 floors, and it's really kind of a contained area, allows people to evacuate down to a safe area where they can await further instruction, connected to the stairs so they could either continue down, they can use evacuation elevators, or they can stay in place until further instruction. The other feature that's been incorporated in most of our projects since Burj Khalifa is evacuation elevators. We recognize that the time necessary to evacuate a super tall building just using the stairs can be 3 hours plus 4 hours. And so we want to be able to get people out of the building more efficiently and more effectively than that. So we've incorporated evacuation elevators. Typically, we utilize the shuttle elevators for that purpose. They're enclosed in standard 2-hour shafts. All of them are provided with emergency power. The elevator equipment and hoistways are protected from water. And we generally recommend that this be done with trained staff. that the elevators actually be operated by trained building personnel, that they go either to the sky lobbies or to the refuge floors, depending on the scenario, and they evacuate people in that way. Some of the operational aspects, really one of the keys to very complex large buildings like this is not only designing them and building them, but having adequate staffing and training and adequate maintenance of the fire protection systems. It's a very key issue. Often we build projects in areas where building maintenance really isn't a high priority, but on a project like this, Supertall building projects, it's a very necessary part. The other aspect of it is to the development of crisis management plans. And we worked on the Burj Khalifa crisis management plan, and really just kind of defining all of the different types of threats and different types of events that can occur within the building, whether they be building system or human-related, weather-related events, and then developing crisis levels for those different types of events and developing the response scenarios that relate to building staff being able to respond. And then finally, training the building staff in how to actually affect those emergency response plans. So, conclusion, we're going to continue to build taller and taller, and as we do, we will continue to look for new strategies and new approaches to how we do that safely and how we maintain the high level of safety in super tall structures. Thank you.
Thank you.